Okay.
Subnetting helps to create multiple networks out of single network. Multiple networks out of single network. Why do we need it? See, whenever you see an organization with various departments meaning you need more network. Every single department needs a, a dedicated and a unique network, a dedicated network. But it is not possible for a company to provide a separate network for each department. The reason is you don't have to keep, you don't have much networks, you don't have much IP addresses, you don't have much networks to give to departments. For example, if I have Department A and Department B, Department C, if I have three departments in my organization, uh, for Department A, I give 10 network. I cannot give 11 network to Department B because 11 is a public network. I cannot give 9 network to Department C because 9 is also a public network. Within organization, we'll be using private network, and in private network, you have three range of private networks. One is 10, another one is 172.16, another one is 192.168.0. But they are of different size. 192 is slash 30, sorry, 24. 172.16 is slash 16 mask. When I say slash 16, you have already gone through the videos, you understand what I mean. The mask is 255.255.0.0, and 10 network is slash 8, which means 255.0.0.0. So when the length of the prefix is not the same, and we don't like to use that. Fine, then how are we going to give these departments with a different network? So we are going to take this 10 network and break down into 10 networks. 10 network, but it's going to be 10.1, 10.2, 10.3, something like that. We are going to break it into 3 subnets and give one for each department. You see, any company you go, you will find only one network. How many departments they may have, we don't know, but each department will have the network starting with same number. If one department net number starts with 10, all departments number, the first octet will be 10 only. There won't be any different, which means for the entire company, their policy is to use 10 network. Or in some company, you will see 172. Means even if they have 100 departments, all the 100 departments, the first number is going to be 172. Maybe second number will vary and third number will vary, right? But this first number will be same for the entire company. Anywhere you go, it's going to be same. For example, Cisco in Bangalore has got 10 network. Cisco in US also will have 10 only. Even though geographically they are in different location, but still their policy is not to use any other network. Only 10 is allowed. Only 10 network. The network, the first octet will be 10. So now let us assume that we have a company with few departments. And So now I'd like to make it neat. Okay, so we got 6 departments here. 6 departments need a unique network. As per the company policy, let's say this is the number 172.16 is what we are supposed to, we are allowed to use 172.16. Other than 172.16, you should not use anything other than this. Nothing. Only this is allowed. So I need to break this network into 6 small networks, sub-networks. The default mask of this network is 255, 255, 0, 0. I need more networks. Already, class B have got these 2 octets reserved. That's the word. In another word, in a common word, masked. That's what they will say. Masked. This is what called as masking, meaning reserved for network. Those 16-bit is reserved for network. In those reserved bits, some bits are on that has given you 172, and some bits are on in the second octet that has given you 16. Which means 170 to 16 will never change. Fine, then how I'm going to have multiple network? We are going to take some bits from here and give it to network. We have these last 2 octets are not network currently. Currently they are host bits. These are not masked. See, they are not masked. 255 is saying the 8 bits are already given for network. This 255 says the above first octet is given for network. In the third and fourth octet, there is no bits given to network so far. This 255 can also be written like this /16, which means 8 plus 8 bits are already given for network out of 32. 16 bits are already given. Now we got another 16-bit for host, and now we are going to provide few networks as network bits, few bits as network bits. We are going to give few bits as network bits so that we can have new networks. Now, giving bits for network, you cannot give from this end. Network will always grow from left to right. You should remember this. Network will always grow from left to right. So you should give from here.
Yes.
And host will always grow from right to left. All right. So there won't be any confusion if we remember this. Now, as we know, this 172.16 is already reserved, masked. You got another 16-bit for you to do as per your desire, use it as per your will. You got 16-bit, 8 plus 8, 16-bit. In this 16-bit, we have decided to give few bits from this left to right, few bits going from left to right for the sake of subnetting. Now, how many bits? If I say few bits, can we give 4, 5, whatever comes in our mind? No. There should be some logic. There should be some way in deciding how many bits to give. For that, early days, in the beginning, this was the formula. 2 to the power of n, where n is the number of bits that you're going to give, n is the number of bits that you're planning to give, minus 2. This was beginning days formula, minus 2. Later it became minus 1. I'll explain you why, and you might have already seen also in the videos. Now, this will give you number of subnets. Number of subnets. So here, n, the small n, means bits we give. For subnetting. That's a small n. Fine, let us assume that I want to give 1 bit from here. For networking. Let's see how many subnets we get. 2 to the power of 1 minus 2 is nothing. No subnetting possible. Fine. Let's try to give 2 bits. I get only 2 subnets. So giving 2 bit is also not enough. Let us give 3 bits. Looks good. So if I give 3 bits,
Sir, excuse me.
yes.
Is this for the subnet or is this to get number of hosts?
No, this is for the subnet.
Oh, okay.
This is to decide how many bits I should give in order to get 6 subnets.
Okay.
In order to get 6 subnets, because I have 6 departments. For each
Right.
department, I need to provide a dedicated subnet.
Yes.
So to get 6 subnets, if you
You
give,
have to borrow 3 bits.
yeah, if you give 3 host bits as a network bit, from now it will be called as network bits. There are no more host
Yes.
bits.
That's right. Okay.
When I gave this 3 bit for the sake of networking, by default it is only 16 bit for networking. After
Yes.
I give it becomes 19 bit.
17, 18, 19.
19 bit. So when it is 19 bit, I can have multiple networks starting
Okay.
1 to 16. Fine. So we have now come to a conclusion to use 3 bits, not more than 3 bit. 3 is more than enough in order to provide 6 subnets. Okay, 3 bit. That's what we have decided. Let's now push this down so that we can use it nicely. Let us go and see this 3 bit story. 172.16 and the 3 bit that we have given, and the remaining bits are still the host bits. Now, this 3-bit is what we have given. The blue 3 bits are what we have given. Now, when you have 3 bits, what are the different combinations, probabilities? We may have all 3 bits 0, 1, 0, 1, 1, 0, 1. If you're not from the computer science background, then it will be a little bit new to you. Now let me explain you in binary. This is 0. This is 1. If you have 1 here and 0 here, then it is 2. This is 2 plus this 1, so which is 3. And if you have 1 here and 2 zeros, which means it is 4. This 4 plus 1 is 5. 4 plus 2 is, see, we have 2 here. 2 is 6. And 4 plus 2 plus 1 is 7. So this is the order in which we can write the different probabilities out of 3 bits that we are having. Another reason why this is called as 4 is if you have 3 bits, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Because it's binary, we'll put 2 raised to 0, 1 and 2. So anything raised to 0 is 1. 2 power of 1 is 2. 2 power of 2 is 4. So whenever you have 0, 0, 1 each, which means it's 1. Because these two are off. 2 multiplied by 0 is 0. 4 multiplied by 0 is 0. 1 multiplied by 1 is 1. And if I have this one, 0, 1, 0, which means 1 multiplied by 0 is 0. 2 multiplied by 1 is 2. 4 multiplied by 0 is 0. So if you apply all this, you will understand that this will give you 7. 1 multiplied by 1 is 1. 1 multiplied by 2 is 2. 1 multiplied by 4 is 4. Add all those, then you get 7. So that's binary system. Now, when we have these 3 bits, you've got 1, 2, 3, 4, 5, 6, 7, 8 different probabilities. 8 different probabilities. 8 different combinations. Sorry. 8 different combinations. Out of which the first and last we are not going to use. All 0, all 1 we don't take. You will know the reason why we should not take after a few minutes. Now when we do, I'll show you. We will not be able to use the subnet because those bits are already given for network, cannot be given for host. But this can be used in the beginning days. They did not realize that. That's the reason you got this number -2 in the formula, because you don't use all 0. You don't use all 1. But later, they found that this can be used, so the formula got changed to 1. Then you will get 7 here. No, let us not get into those things. Now let's go with the old one first. Initially, the formula is 2 to the power of n minus 2. Why minus 2? Because you don't use all 0 and all 1. Okay. Now, what is that you are trying to do with this? When you apply this one here, what we get is, in this place, it is 2 to the power of 5. How? This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. This place is 2 to the power of 5, which is on. The face value of 2 to the power of 5, meaning what is 2 to the power of 5? 2 to the power of 5 is equal to 2 into 2 into 2 into 2, which is 8 multiplied by 2, 16. Is it 16? No. 0, 1, 2, 3, 4, 5. 2 into 2 into 2.
I think it is 32.
Another 2. Yeah, I forgot to put another 2. It's 32. 32. So we need a reference to do this easily. So what I'll do is I'll write here 8 bits. This 8 bit. 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 0, 2 to the power of 1, 4, 8, 16, 32, 64, 128. So total 8 bits. Because we begin with 0, it's 2 to the power of 7, not 2 to the power of 8. 2 to the power of 7 is the 8th bit. Now this is what called as face values. Now, when we have 1 here, which means we need to consider that face value. So our first department, this one, is 172.16.32.0. In the third octet only, you have given 3 bits. First octet, second octet, third octet. So the 32, you should not write it here. We should write only the third octet from where you gave. Fine. So we learned the first network of this first department. So the first department is going to have 172.16.32.0 as the network. Okay. Now what about the second department? For that we put 1 here and 0 here, which is 2 to the power of 6 is 64. You see? Yeah, 64. 172.16.64.0 is the next department's network. Now, when you apply this one, it is going to be 64 plus 32 because both the bits are on. 64 plus 32. 64 plus 32 is 96. So 172.16.96.0. When I apply this one here, 100, the value on this 2 to the power of 7, the face value is 128. You can see it here, 128. So 172.16.128.0 will be the fourth network. So we got the network for first, second, third, and fourth. And now this is going to be the fifth, 101, which means I need to add 128 plus 32. 128 plus 32, which will be 160. So in the third octet, 172.16.160.0. Next to these two. This is 128 plus 64, which is 192. So 172.16.192.0. Right. Now for sixth department, we got 6 networks. But this is not really 6 network unless you write the mask correctly. If it is slash 16, which is a default mask, only these 2 octets are network. So the 2 octets are same everywhere. Then it cannot be called as different network. Only when you extend the mask, you cannot simply keep it as 255255. You should put some number here to say I have given 3 bits. Here you have given 8 bits, so it is 255. Now you have given only 3 bit in this octet. When you add the 3 bit, what do you get? 128 plus 64 plus 32. 224. We get 224. That we have to mention, otherwise there is no use of doing subnetting. So we have to say the new subnet mask for this network, the subnet will be 255, 255, 224, 0. We need to say this. 255, 255, 224, 0. Otherwise, you should at least say slash 16 plus 3, 19 everywhere. 16 is the default mask. Now 3 more bits we have given. So we should say this. Only then this will be considered as different networks. So it's no more in this level, it is now extended. We're extending the bits. The network bit is added more. The host bit got reduced because we gave some bits for networking. Yeah, so writing mask is very important. Very, very important. Okay. Now, this is the actual logic applying those combinations. But there is a shortcut also. If you are going to give from this bit for network, this this bit for network from 2 to the power of 5. What is 2 to the power of 5? 2 to the power of 5 is 32. You just keep incrementing by 32. 32, again 32 plus 32 is 64. 64 plus 32 is 96. Keep adding, adding, adding until you reach this number that you have in the subnet mask, 225. So 172.16.224.0 we don't use. I told you all ones we don't use. And all are one. That's the max. You cannot go beyond it. We don't use. Now why I cannot go beyond 224? Because we have given 3 bits for network. Out of 255, the first 3 bit is already given for network. If you try using this, what will happen? Your first IP will be 172.16.224.1 and your last IP will be 172.16.255.254. Now, how did you get 255 when you have already given 3 bit for host? Not possible to get 255. 255 you will get only if you have all 8 bits for the host. Do we have all 8 bits for the host? No, we have already given 3 bit. So we don't use all 1. That's correct. We cannot use all 1. And all the given bits are 1. You cannot use that network. So we can use only this 6, and we want only 6. We got only 6 departments. Fine. In that subnet 6 subnet, we are going to write the first IP of each department, each subnet. For each department, because you got different network, you will get different broadcast address. What is a broadcast address? The address that will deliver the packet to everyone in that department. The address to which you can send so that the data that you have sent will be delivered to everyone, but only in that department. Everyone in that department will be receiving it. Very nice. If you don't have subnetting, then you will have only one common broadcast address. And if you will send a packet to that address, it will be going to all the members of every department, which is not okay. So, in order to deliver the packets to only those members of Department 1, you need a separate broadcast address. For Department 5, you need a separate broadcast address. So let's see now how the broadcast address we can get for each department. So if you have a network, there should be a first IP, there should be a broadcast IP. So I'll write broadcast IP and then the last IP of each department. If you know first IP and last IP, you know what all comes in the middle. Always the last IP of a network is the broadcast IP. The last IP means what? All the host bits are on. All the host bits are on. That is what broadcast IP is. Now, to easily get the broadcast IP, you need to see the next network. The next network is 64, which means it is 172.16.63.255 is the broadcast of the first department. See, the second department is 64. If you just add one bit to this, you will get 172.16.64.0, which is this one. How? When you add 1, what will happen? 255 plus 1 is 256. There is no 256. So 1 will be carried here. 64. 63 plus 1, 64. So what I'm trying to say is the broadcast IP of department 1 is 1 bit less than the next network ID. 1 bit less than the next network ID is the broadcast of this department. The broadcast of this department is the address which is 1 bit less than the next department's network. Now, the first IP of this department will be 172.16.32.1. The last IP is 1 less than this. Don't reduce here, you need to reduce here because we are talking about host. Host will grow from right to left. So 172.16.63.254. 1 less than this number, 1 less than the broadcast address. See, you got lot of host here. In 32 you have 255. 33 you have another 255. 34 you have another 255. 36 you have another. Likewise, you go up to 63. Right. So we got the first network and the first network's first IP, the last IP, and the broadcast IP. Likewise, we are going to now write the first, last, and broadcast of each department. For department 2, the first IP will be 172.16.64.1, and next department 172.16.96.1. The next department is 172.16.128.1, 172.16.160.1, and then 172.16.192.1. These are all the first IP. And then the last, let's write the broadcast. The broadcast will be 172.16. If the next network is 96, then it is 95 here, .255. 172.16. If the next network is 128, then it is 127.255. Next network is 160, then it is 172.16.159.255. Next network is 192, then this is going to be 172.16.191.255. Listen, the reason why I wrote this one is, even though we don't use, it helps me to write the broadcast of the last department. 172.16.1 less than this, which is 223.255. So I got the first and the broadcast for all the 6 departments. Let's fill the last IP. The last IP will be, I'll just write 172.16.95.254, 127.254, 159.254, 191.254, 223.25. Oh, writing is always bad. Yeah. So we now have the subnetted 6 departments dedicated first, last, and broadcast IPs. This is how we do subnetting. But again, this is not all subnetting. We have a lot to learn in subnetting. This is the very first step to understand subnetting. This is like we are given with 6 departments and we are asked to do subnetting by giving a network. 1 to 16 is given to us. But what is not given here is how many IP address per department is not given. So based on host, based on how many IP address we need, the subnetting method will be different. This is simply based on how many departments you got, 6. Then how many networks you need, 6. Based on this info, this is how we do the subnetting. Please copy this and ask me question.
Yes, sir.
You comfortable? You don't have any question?
So if you're given like 172.16, which is a subnet mask of
Slash 16.
16 network, you don't start from 172.16.0.0. So that's your first network, and then your next network is 172.16.32.0.
See, you're saying after subnetting, right? After subnetting.
Yeah.
Okay. That is what later they realized that we are
Oh, okay.
wasting that zeroth subnet.
Okay. Because
Initially,
what?
initially the formula was not
Okay.
-1, it was -2.
Right.
The reason why
-2.
-2 is we were not using that all zeros.
The first and the last.
We
Okay.
are not using this. Now what you are talking about is this network,
Okay.
this prefixes. So later we realized that we are wasting this range of IP address, and it got added later. The reason why
Okay.
I specify this is sometime, not every time, in some exam in Cisco, if they don't mention zeroth subnet,
Mm-hmm.
if they don't mention zero subnet, which means they have applied the old formula.
Ah, okay. Okay.
So they mention it very clearly, it's zero subnet. See, if only they
Right.
mention zero subnet, this will become the second network.
That's right. Yes.
If not, this is the first network. So
Yes.
that is how Cisco works. That's why I teach separately. Fine. Then, if you have copied, I'll give you a small assignment to do now. Are you ready? Have you copied this?
Uh, yeah, I
Okay.
did.
Now I'm going to give you a question. I'm going to do later after you finish. I'll do. So you're going to do now. This is the network 192.168.0.0, and I have three departments. No, no, no. Let's say two departments. Two
Okay.
departments only. Now, your job is to give me the new subnet mask and then the first subnet, which is for the first department, second subnet for the second sub department, and then you need to give me for each subnet the first IP, the last IP, same like what I did in the above broadcast
Okay.
IP. All right, now you can start. So you should remember the lesson that you learned in this. uh,
Yeah.
when you do the subnet mask, the default subnet mask first you need to check what class it belonged, and then
Yes.
you need to borrow from the octet which is
The
available.
next bit.
Now these are the homeworks and same rules, but the number of departments here for this is 5 for this one is 6 department. For this one, it is 4 department. Right? All other things are same. You need to write the new subject mask for each. You need to write the first and the last and broadcast for each subnet.
Okay.
Will you be able to do it?
Yes, sir.
Okay. So present.